A helpless frog is launched from a cannon at an angle of 30 degrees at a velocity of 12 meters per second from the top of a 20-meter cliff. How far did the frog travel horizontally before landing? All right, so got a little sketch. My frog's eating I think that's a moth. I'm not sure. I tried to make it a butterfly. Maybe some color will help. But anyway, he's getting out of there. He's tired of this cliff. He's jumping out at 12 meters per second, 30-degree angle. If you see an angle in physics, always, always, always break that sucker down into components. Two-dimensional problems are too hard to handle, so we break it down into two one-dimensional problems. Velocity in the y, you're going to use sine because that is the opposite angle. This one right here. And then for velocity in the x, you'll use cosine because it's the adjacent angle. All right. After a while, you just kind of get the hang of which one to use. Hopefully, that's starting to feel routine to you by now. We're looking for delta x here. I don't know why I wrote 2. We don't know what delta x is. All right. So let's move on to our chart where we throw all these values in. So we've got values for y. This is kind of the starting stuff. I'll box it up. This is what the problem told us. And everything else is calculated after that. Everything else is work that I've already done. So we know that the initial velocity in the y is 6. Acceleration is always 9.8 down. Do not forget to throw that negative on the 9.8 or it's going to mess you up. And delta y is 20 meters down. This was the number one mistake I saw last year. 20 meters down. You must throw the negative on it or you're in for a lot of headaches if you don't. All right. This equation's our guy. We're looking for t and we have all this other stuff. Delta y, 1/2 at squared, all that good stuff. You throw the numbers in, and then from here, we have a t squared and a t in there, which means we'd better run the quadratic formula. There's no other way to pull that t out. There's no shortcuts on this one. So make one side equal to 0 so that we can run the quadratic formula. I went ahead and skipped it here. I just did it in the calculator. If you want to, you can just graph it and find the 0. That's a shortcut that you can use on the free response if you want. But you should get t equals 2.7 seconds. We shuttle that answer over to the x direction, right? Because the frog spent just as much time going right as he did going down. So since time is the same, we can take advantage of that. And now that we're armed with the knowledge that t equals 2.7, it's pretty simple because the velocity is constant in the x direction. And constant velocity is a piece of cake. It's just how fast were you going, 10.4 meters every second, times how long you were doing it. You were in the air for 2.7 seconds, which means you traveled about 28 meters. So about a quarter of a football field. That's a pretty nice shot for just little Mr. Frog. All right, good luck on the quiz this week, guys.